All right. So these are the answers that I obtained for these 3 problems. 98 feet squared for the first one. The second one I got 170 inches squared. And the third one I got 122.75 meters squared. CJ, I saw your hand.
Can we do number 1?
How can I look at number 1? Some of you got it right when I was walking around the room, so some of you have the right thoughts. How did you get that answer, Ryan?
I just made the left triangle have the base of 10 feet and the right one of 4 feet, and then I did base times height of each one divided by half, and then added them together.
Okay, so you gave yourself some arbitrary values. Okay, is that legal?
No.
I guess you could technically. I mean, he said that he let this be 10, you said, and you let this be 4. You still got the same answer? And treat us 2 triangles. Okay, how else could I look at this? Apparently it worked. Brandon?
You could make it into a giant square.
Oh, a giant square, okay. So I made it into a giant square. Then what?
So I found the area of the big square, which is 196.
So the area of the entire square was 196. You got that by doing what?
14 squared.
14 squared. Okay, then what did you do to that?
I subtracted the area of the middle triangle since that's just a gap.
Okay, so then he cut out the area of the middle triangle, but like he said, that's just going to be half of it. So you essentially cut this in half, right?
Yeah.
And then you got
98.
98. Because, like we said yesterday, a triangle is always half the measure of its parallelogram that it's composed of. Okay? So if you take a square out and you cut a triangle out of it, it's going to be half in this situation. Now, Ryan's way works also because he's saying that he let this be 10 and he let this be 4. Okay? 10 and 4 is still 14, right? Does that make sense? Yes? No? Well, let's try it. Okay, so Kyle is questioning whether or not this always works. So let's change this to 9, and this would become what? 5. So then let's try 1/2, 14 times 9 plus 1/2, oops, that'd be a 5. 5 times 14. Did I set that up right? Half of 14, 7. 7 times 9 is? Okay. Half of 14, 7. 7 times 5 is? Did it work?
Yep.
So even though it kind of seems illegal in the world of math to give yourself some variables, it's still, or give yourself some values, normally it is illegal. In this situation, it worked. Okay. Could I put angle measures inside that triangle? Is that legal? Is that kosher? Can't put angle measures that are not given to you inside those, okay? All right, you like that first one now? A little bit better? This is how I saw it, in case you're curious. I imagined myself just visually pulling this point all the way to the end. And if I pull this point all the way to the end, that right side triangle just disappears, right? And so then just like what we were talking about is it's just a triangle. It's just the 1/2 the base times the height of 14 and 14, which is the same method as what Brenda was discussing. I essentially just moved this, okay? Does that make sense? How about 2 and 3? You okay on 2 and 3? You want to talk about 2 or 3? Sure. Okay. All right, so I will leave you with this remark. Some of you cut number 3 like this. And when you cut it like that, you cut it into this shape right here. What shape is that? A trapezoid. Have we reviewed how to find the area of a trapezoid yet? No. Today, though, however, I get the privilege to review that with you. Okay? So today we are focusing in on finding area of trapezoid, rhombi, and kite. At the very end of class, you'll have your check for understanding, just like we did yesterday. Homework this evening, again, Math Excel 15 questions. I have a thought for you on your quiz on Friday. This does not permit us to have review time, okay? We don't get to have a whole review day reviewing area formulas for these shapes. But these fine, lovely questions right here from your warm-up, I obtained these from the additional practice worksheets that are available to all of you on Schoology. So please remember, on Schoology you have additional practice worksheets for all the sections inside of our textbook. Remember us talking about that a long time ago? Have any of you used them anytime recently? Some of you? Okay. Alright, here we go, trapezoids. You can find the area of a trapezoid when you know its height and the lengths of its bases. Remember height, we still need to recognize that height is the concept of an altitude where we go from an opposite side and we are perpendicular, okay? So here is my trapezoid. To find the area of the trapezoid, what I'm going to do is I'm going to take half times the height. This is specifically my height right here because I'm seeing it form a right angle with one of the bases. Recall bases of a trapezoid. By definition, the bases of a trapezoid are the two sides that are parallel to one another. Okay, so I'm going to do 1/2 height times the sum of the bases, which means I'm going to do base 1 plus base 2. Okay, do you remember learning that formula a long time ago? Maybe a little bit? Alright, here is my example problem. What is the approximate area of Nevada? Nevada approximately makes a really pretty trapezoid shape. So here we go. Area formula. Area is equal to 1/2 height times base 1 plus base 2. That's kind of where I start off on all of my problems. Alright, but now I need to figure out who is who. What am I going to use for the height inside my trapezoid? 309. Very good. So 309 is this distance right here. This is my height, which means my other two sides, which are parallel to one another, this guy is parallel to this guy. These are my bases, okay? So we're going to have the length of base 1 plus the length of base 2. Does it matter who I choose for base 1 and base 2? All right, what am I going to add? So 205 and 511. So these are big numbers that I would expect probably you're going to do what with them? Type them into your calculator, right? Alright, so I typed those into my calculator and I got 110,622, and that is an approximate answer. Miles squared. You like my answer? Because it's an approximate answer, I should probably put the squiggles, okay? Because did I round on this? When I typed it into my calculator, did I round? Yes? Did I? Didn't I? I didn't? Okay. I did not round. All right. Oh, Mr. Porterfield, you missed our introduction. All right, it's got time. Did you get our lovely formula for the trapezoid? And cross out this word, because apparently we don't need approximate. Okay. You ready to check this answer? Alright, let's pull it on out. Alright, I'm hoping you got 94.5 centimeters squared. See? Alrighty. Ready to move on? Alright, so if you recall last chapter, I emphasized certain topics. Here is the first return of one of the topics from last chapter. What is the area of this trapezoid PQRS? So we now know our area formula for a trapezoid. We got 1/2 the height times the sum of our bases. In this trapezoid, it does not appear that I have all the information, does it? What piece of information don't I know?
Height.
The height. I don't know the height. However, I can create a triangle, correct? So I'm going to zoom in on this triangle, if you will. Okay? Zoom in on this triangle. Height is perpendicular, that's why I know that's a right angle. I know this is 60 degrees, and I now know that this is the height. Now, Heidi, I'm going to correct you on this, honey. If we are across from the 60 degrees, we are not the short leg. We are the long leg. And we need to remember our relationship. The long leg is equal to what? Radical 3 times the short leg. All right. So that tells me that I need to think about this. What is the measure of the short leg? How'd you get 2 so quickly?
7 minus 5.
Very good. So you saw that this is 5, which means this is also 5. And if the entire length is 7, this piece here has to be 2. Good, Griffin. So if the short leg is 2, that tells me that my height is what? 2 radical 3. What you are going to notice in this section and on your quiz on Friday, if I ask you for an exact answer, it means you're probably using a special right triangle, which means I want to see a radical in your answer. All right, we're now going to plug this in. So we have 1/2. You did a great job. You found your height is 2 times radical 3. Base 1 plus base 2, we have 5 plus 7. I'm not typing this into my calculator, because if I type this into my calculator, it's going to give me a decimal, and my answer is no longer exact. Because the moment you type in a decimal, you're going to be forced to round when you go to write on your paper, right? When you round and you make the executive decision just to stop somewhere, it is no longer exact. So let's practice this guy. 5 plus 7, what is it? So we have 1/2, 2 times square root 3, we times by 12. All right. Common misconception I still see on some of your papers. I see some of you distributing the 1/2 to both of these. That is not legal. That is not kosher. You only give the half to one of them, and you get to choose which one. Which one do you like? The 12? Okay. What is half of 12?
6.
So this becomes 2 root 3 times 6. What is 2 times the square root of 3 times 6? 12 radical 3. Very good. This is an exact answer. When you see those bolded, underlined words on your quiz, when I want exact, that's what I want. But the other thing I need to see in this unit is a unit. What's my unit measure here? Very good. Okay. Questions on my example problem? Yes, Heidi?
Could you also just multiply the two values in parentheses and then do it by half?
Absolutely. Okay. All right, we good? Yes, Ryan?
Have you ever drawn the triangle from like the top of R and then down? Or no?
If you draw a triangle with R, I'm not sure how you're going to connect them, but you're going to change the angle measure, right? I guess I'm not seeing the triangle you're seeing. What triangle are you seeing?
I don't know. I was just thinking.
Well, this height will be the same height as over here, right?
Yeah.
That I know. But what I want to do is I want to do it off of this special right triangle that's been given to me, essentially. Okay? All right, in yours, I am going to change your height. So your height is going to get smaller. The reason it gets smaller is I've changed your angle measure for P to 45 degrees. So if you want to draw a different picture, you can. But you need to remember your 45-degree rules. Gotta remember your special right triangles. They're not only going to make an appearance today, they will make an appearance tomorrow. Nope, because it's no longer exact. Well, that's what we're going to use in section 5. I don't want you using that yet. It would work, but it's no longer exact. Okay? So that's why I'm warning you on that. All right, you ready to check your answer on this one? Yes? All right, let's check it. All right, did you get a nice answer of 12? Yes? Did I give you a nice triangle to deal with, 45, 45, 90? Do you have questions on this one?
Yeah, why is like the height too?
So you got to remember that if it's a 45, 45, 90 triangle, we already discussed why this is 2, right?
Mm-hmm.
What do you know about 45, 45, 90 triangles? They have to have the same legs.
Wow.
So that's why your height has to be 2. You should not have to do a calculation on that one, okay? All right. I'm going to bring up what Meredith just asked me. Meredith asked me on this first question, why couldn't she have just used tangent? Tangent of 60 degrees. Tangent of 60 degrees is going to get you an exact answer. We will return to using SOHCAHTOA in section 5. But using SOHCAHTOA right now is not going to get you your exact answers, okay? Alright, so those were the trapezoids. Time for the kites and the rhombuses. Alright, to find the area of a rhombus, or the area of the kite, either or, they both have the same formula. All you need to do is multiply the lengths of their diagonals and then cut them in half. So you have half of D1 times D2. Where I need to point this out to you. When I say diagonal 1, I want the entire length. When I say diagonal 2, I want the entire length. Okay? Reminding you of a property of a rhombus, just so you know. Rhombuses, they are parallelograms. Back in chapter 6, we talked about properties of parallelograms, and one of the properties of parallelograms was the fact that diagonals bisect each other. So these two pieces are congruent. This was not a true fact on kites. Okay? Alright, here we go. Problem 1. What is the area of this kite here? KLMN. Area formula. We got 1/2. Diagonal 1 times diagonal 2. Okay? Doesn't matter who I choose, does it? For diagonal 1, diagonal 2. Alright, diagonal 1. Let's let this be diagonal 1. What is the length of this diagonal?
6.
How'd you get 6 so quickly?
They're each of the sides of
Very good, each of the sides of 3. Alright, let's let this be diagonal 2. What is the length of this diagonal? Very good. So there's my setup. Again, this probably should be one that you should be able to do without a calculator, right? What's half of 6?
3.
What's 3 times 7? 21. I'm glad you still have some math skills. I like that. I was getting a little scared about that. What do I do? Why is my answer still losing half a point? All right, good. Call me out. Call me out. You got to do it. Sure to do your got it? If you didn't do your got it, I bet you can do it real quick. Probably can figure out now why we're quizzing on Friday.
Do you need to show work for these problems?
Technically, you should. And the reason why I warn you on that is I can't tell you the fact that there are so many children who mistype something into their calculator and then they get the wrong answer. And then I got to take off the whole question. They're going to be really sad because they just typed something in wrong. So, like on the last test, I had people correctly show me that they were going to do sine inverse of something, but then something wasn't going right. I still gave them most of the credit, but I had to take off some point for not getting the answer. Okay? Alright, answer you should get 54 inches squared. I actually didn't take off any points for not showing work on certain questions on the last test. Okay? Alright, last problem. The high occupancy vehicle lane is marked by a series of diamonds. I don't know if we actually have any of these lanes in Columbus, and most of you are not driving yet. But here's the shape that it creates. Okay? These are also called rhombuses. What is the area of the HOV lane diamond shown at the right? Okay, so we know that to do area for this, we need to do half diagonal 1 times diagonal 2. Okay? Do I have enough information? Just by looking at the picture, am I ready to just plug things in? Okay. I do know some of it, though. I know the length of this diagonal, correct? What's that diagonal? Alright, so far we know we have half of 5. But we know we have to have something else. So what I'm remembering is the fact that a property we have is the fact that their diagonals are perpendicular. So perpendicular means I can focus in on this shape right here. What shape do you see? A right triangle. We just spent an entire chapter dealing with right triangles. I ultimately care about figuring out this length right here. What could you use to find that length right there? Pythagorean theorem. A lot of you forgot about that tool in your test this past week. So if we need to use Pythagorean theorem, we need to recognize that x is a leg. It is not a hypotenuse. X squared plus 2.5 squared equals 6.5 squared, right? So ultimately what I'm going to do to isolate x is I'm going to subtract the 2.5 squared to the other side and then take the square root, correct? So x is equal to the square root of 6.5 squared minus 2.5 squared. Somebody help me out. What is our little side note equal to?
6.
Exactly 6? How convenient. Alright, so now I'm plugging in 6 right there. And now it's a really easy problem. Wait, 6? 6 is just that piece, isn't it?
Yeah.
What do I gotta do to 6?
Double it.
Gotta double it, okay? Because I gotta recognize that this is also gonna be a length of x over here. So I don't wanna plug in x, I wanna plug in 2x, okay? Bet I've seen that mistake before. In fact, I almost made it. Alright, so that should be what number? 12, okay? Alright, half of 12 is
So
6 times 5.
30.
Alright, so 30 and Heidi's all on it. She says feet squared. Questions on that? Did you already do your got it? Alright, if you have not already done your got it, please do so now. If you want to wait to check your answer, you can. Otherwise, you can log on to Schoology. Remember, you have a check for understanding on this content. You may use your notes. Please be warned once again, you do not get to have formulas on Friday. You do need to know them in your heart. Okay? I'll wait just a little longer. Do you want me to pull it out for you, those of you who are ready? Don't look if you're not ready. Don't look. $96? Those of you who aren't done yet, just pause, just wait. It's okay. You have time in class because we don't get out until 49 after, which means there are still 19 minutes left in class. So if you don't quite understand this, got it, and you want to make sure you understand it before you move on to the check for understanding, just call me on over. I'll be right on over. Somebody said yesterday that I sound like one of those airline attendants when I talk like that.